Hello and welcome everybody. Today we're going to be looking at 3.2.3 core problems. This is pages 149 through 150 in your book. It's 51, 53, 54, and 57. Those are the 4 problems I would like you to complete and turn in. So let's start off with the introduction. It says, how can I multiply integers? And normally we look at multiplication as repeated addition rather than subtraction. And what I mean by that is when we have something like 3 multiplied by 5, and sometimes you might see it as 3 with the multiplication symbol and then 5. You would think about it as 3 groups, right? The number out in front is telling us how many groups we have. And then the number afterwards is telling us the number that we're going to have in each of those groups. So in this case, 3 times 5, I would do one group of 5 positive tiles, a second group of positive tiles, and finally a third group of 5 positive tiles. So there we see it's basically like saying 5 plus 5 plus 5, but it's far easier and quicker to just write 3 and then in parentheses 5. And so here we have 1, 2, 3 groups of positive 5. But here we're going to be representing multiplication as repeated subtraction. So we're going to be using negative tiles this time for subtraction. We're going to be taking away numbers, all right? So for each expression below, predict what you know about the result without actually calculating it. Can you tell if the result will be positive or negative? All right? Also, can you tell if the result will be smaller or larger than the number you started with? So let's take a look at A here. We're starting at -1 and we are subtracting -6. So here, since we're subtracting a negative, we could change it to adding a positive, right? And so here, -1 plus 6.5, that's going to give us positive 5.5. So the number is going to be larger in this case than what we started with. And it's also going to be a positive result because we are subtracting a negative, which is adding a positive. Now we're looking at B. Same thing here. We're starting at 2.2 and we are subtracting a negative. So there we can rewrite it as 2.2 plus positive 2.2. So here we'd end up at 4.4. So my answer is going to be larger than what we started with, and it's going to be a positive answer. We'll do one more together. We'll do E. E says we have -10, and then we have minus -2, minus -2, minus -2. Well, I can rewrite this as -10 plus 2 plus 2 plus 2, right? Because those negatives essentially cancel out, the subtracting a negative. And so here now I can think about it as 10 plus positive 6, and that would just give me -4. -4 is larger or greater than -10 because it's closer to 0. So here I'd write my outcome is going to be larger, and it's still going to be negative because -10 is bigger than positive 6. So I'm going to stay in that negative part of the number line. All right, so now you guys are going to complete C and D on your own. 353, Troy and Twana are working with the expression -10 minus -2 minus -2 minus -2. So just like the problem we looked at. First off, help them find a shorter way to write this expression. Well, we said they could write it as -10 plus 6 if we want to write it as an addition statement, right? Because these negatives turn into adding positives. But we could also write it in another way, just like we see it above, -10 minus, and here we have 3 groups of -2, right? 3 groups of -2. So I can write it as 10 minus 3 groups of -2. Now it says, imagine that their expression does not include the -10. How could they write this new expression? What number would this new expression represent? If you were to describe this expression using positive, negative tiles, what would you say? Okay, well, if I got rid of this -10, I still have minus 3 groups of -2. So you can think about that as taking away 3 groups of -2, or what I'm actually going to do here is instead of this being minus 3 groups of 2, I'm just going to make this -3 groups of -2. All right? So you can think about it as -3 times -2. Or take away 3 groups of -2. So now I'm going to show this using tiles. And what I'm going to do is put 3 groups of -2. There's one group, there's 2 groups, there's my third group. So right now I have 3 groups of -2. And now I'm going to take away, right? Because I have that subtraction sign, or you can think about it as a negative sign. So I'm going to take away 3 groups of -2. But before I do that, I need to have a neutral field, meaning that this needs to equal 0. So I need to put my positive tiles here before I take away my 3 groups of -2. And now I can just go ahead and take these away. So they're no longer with the positive tiles. I'm going to go ahead and actually erase them. And now what am I left with here? Well, I'm left with 6 positive tiles. So my answer here is going to be +6. That's how many tiles I have remaining when I took away my 3 groups of -2. Because remember, we started with a neutral field, meaning that when I write 6 positive tiles and 6 negative tiles, that's going to equal 0. But I had to do that so I could take away my negatives, leaving me with 6 positives. All right, now we're looking at 354. How could you evaluate the product -7 multiplied by -11? All right, so let's think about what this is saying here. It's saying -7 groups of -11. And that's kind of tough to think about, -7 groups of -11. So I'm going to actually think about this as a subtraction statement. I'm going to think about it as minus 7 groups of -11. Because now this is reading as take away 7 groups of -11. So let's go ahead and do a few groups here. Our first group of -11, 4, 5, 6, 7, 8, 9, 10, 11. And then I need a neutral plane field, so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 positive tiles as well. And here now we have our neutral field, just like we did in that last problem. So this here all equals 0 right now. It's just going to allow me to take away now -11. So again, we call this a neutral field, or we can think about this as 0 pairs. And now I'm going to take away -11. So let's go ahead and do that. All right, what am I left with here if I take away my -11? Well, I have 11 positive tiles still. And that's just one group. So now if we have 11 positive tiles after one group, and we kept writing this over and over again, then we would end up with 77 positive tiles. So that's why -7 multiplied by -11 gives us positive 77. And you can also think about this in terms of if you're multiplying a negative by a negative, right? Opposite by an opposite, I'd say, then you'd end up with a positive. All right. 357. What does -18 divided by 9 equal? How do you know? Explain why your answer makes sense, and then complete the division problems below. All right. So we can think about this in terms of fact families. In other words, if I'm looking at 45 divided by 3, well, I could rewrite this as -3 multiplied by what gives me positive 45. Well, we know that if we were to multiply a negative by another negative, it's going to give us a positive answer. So I know it's going to be a negative number here, and 3 times 15, right? 15, 30, 45. That's going to give me positive 45. So -3 times -15 gives us positive 45.